Okay, this is 5.1 notes. We're working with inequalities. I want to go ahead and remind you how we did solve an equality with an equal sign. This is a two-step problem, so we need to look at our problem. 2x plus 4 equals 10. And if I want to solve for x, then I need to get this term by itself. And I have plus 4 added to it, so we're going to subtract 4 from both sides. And I get 2x is equal to 6. And then I have the x term by itself now. Now I need to get the variable x by itself, and so I have 2 multiplied to it. So the opposite of multiplying by 2 is to divide by 2. And I get my x is equal to 3. Now I want to solve the same problem, but now it's written as an inequality. And this says 2x plus 4 is greater than 10. So I want to know what all the x values are that will work for this inequality. And guess what? It's not solved any differently. I'm still going to subtract 4, and I get 2x is greater than 6. And 2 is still multiplied by x, so I still have to divide it. This time the only thing that changes is my sign. X is greater than 3. So the difference here is that this solution has to be exactly 3 and 3 only, whereas this one can be a number of answers starting at a number greater than 3. So x is greater than 3 means it could be 4, 5, 6, 7, 100. Any number that's greater than 3 would work for this solution. Now we want to see how the operations affect the inequality. So we're going to use this base inequality. Negative 4 is less than 8, and that is a true statement. Negative 4 is less than 8. What happens when I add 2 to both sides? Well, I get negative 2 is less than 10. Is that true? Is negative 2 less than 10? Yes, it is. So that is true. So I can add a number to both sides and the inequality will still be a true inequality. What happens if I subtract 3 from both sides? I get negative 7 is less than 5. Is that still a true statement? Yes, negative 7 is less than 5. So that's true. Okay, what about multiplication? What happens when I multiply both sides by 3? I get negative 12 is less than 24. Is that a true statement? Yes, negative 12 is less than 24. What if I multiply by negative 2? If I multiply by negative 2, I get negative 4 times negative 2 is 8, is less than 8 times negative 2, which is negative 16. Is 8 less than negative 16? No, that's false. Well, let's see what happens when we divide. Negative 4 divided by 2 is negative 2, is less than 8 divided by 2, which is 4. Is negative 2 less than 4? Yes, that's true. Okay, what happens if we divide by negative 4? Negative 4 divided by negative 4 is positive 1. Is less than 8 divided by negative 4 is negative 2. Is 1 less than negative 2? No, that's false. So it seems like we're only really running into a problem with our inequalities being true is if they are being multiplied or divided by a negative number. So in order to correct that, in order to make 8 and 16 correct, I'm going to have to flip the inequality sign. So whenever you multiply or divide by a negative number, you're going to have to change the inequality sign. Because now if I flip it, 8 is greater than negative 16, then that's a true statement. And if I flip this one, 1 is greater than negative 2, then that's a true statement. So when it comes to the positive and negative, to multiplying or dividing by a negative number, we're going to have to flip the inequality sign. So, in our scroll here, when you multiply or divide by a negative, I'm going to put negative in big words, big letters, you must flip the inequality sign. Okay, so whenever you multiply or divide by a negative number, you must flip the inequality sign. That's the only way that it's going to be a true statement. Okay, solving and graphing the solution set on a number line. So we are going to be graphing on our number line, and we're going to be solving. Solving is going to involve all of the things that we learned last semester with distributive property, combining like terms, moving all of our variables to one side of the equation, all of our constants on the other. So in this case, this is going to be a multiple step equation, and I see 2x minus 3 is greater than 7 plus x. I personally like to move my smaller variable over to the larger one. So in this case, I'm going to subtract x. It kind of keeps them positive. And I combine like terms and I get an x left. Minus 3 is greater than 7. Okay, so if I'm going to solve for x, that means I need to move this negative 3. And again, we do the opposite. Add 3. And I get x is greater than 10. Okay, going back over graphing. If we have less than, that's going to be an open dot. It means it goes up to that point but does not include it. And if we have greater than or equal to, we're going to have the solid dot. And the same thing if we have less than here or less than or equal to. So x is greater than 10. So that means I'm going to have an open dot, and I'm going to indicate I can use any of these numbers that are greater than 10, so that my arrow in the direction is including all of those points that are greater than 10. Okay, number 2, we have the distributive properties. So that means I'm going to multiply w by 3 and get 3w. And I'm going to multiply 12 times 3, which gives me 36, and that's less than 0. Okay, solving for w, that means I need to reverse adding 36. So I'm going to subtract 36 from both sides. And I've got 3w is less than negative 36. And I'm going to divide by 3. And w is going to be less than negative 12. Okay, so w is less than means I'm going to have an open dot, and less than 12 means all of these numbers to the left of negative 12, all of the numbers that are smaller than negative 12. Number 3, we have 6p is greater than or equal to 10p plus 8. I think I am going to move my 10p because 6p is already by itself over here. And that's going to leave me with negative 4p greater than or equal to 8. Then I've got to divide by negative 4. So that gives me p, and that gives me negative 2. But remember, whenever I multiplied or divided by that negative number, I've got to flip that inequality sign. So that's going to change directions and become p is less than or equal to negative 2. Okay, remember whenever you multiply or divide by a negative number, you've got to flip that inequality sign. Well, this time my sign is less than or equal to, so that means I'm going to have a solid dot, and p is less than negative 2, so that means everything to the left of negative 2 is going to be a solution. Number 4, 4 minus 2m is greater than 7, so I'm going to subtract 4 from both sides. And I'm left with negative 2m is greater than 3. And then I need to divide by negative 2. And again, I'm dividing by a negative number, so that means I'm going to have to flip that sign. M is now going to be less than negative 3 halves. If you want to do a decimal, that's going to be negative 1.5. Negative 1.5 is located here, and it's going to be an open dot in the middle. And less than, so it's going to be to the left side, everything less than negative 1.5. Okay, number 5, we have a multiple step problem here. The first thing I'm going to need to do is to distribute. Remember, when I distribute, I take the number and the sign in front, so I'm really distributing a negative 7. So I get 8h minus 30 minus 7h plus, because a negative and negative is positive, 21 is greater than 2h. From here, I want to combine like terms, so I have an 8h here and a negative 7h. That gives me 1h. And then I have a negative 30 and a positive 21. That gives me a negative 9 is greater than 2h. So I'm combining like terms, combining my variables with variables and my constants with constants. Okay, I'm going to move my h since 2h is over here on its by itself, so I'm going to subtract h from both sides, and I get negative 9 is greater than h. Well, I see my number line is not big enough, so I'm going to extend it. 6, 7, 8, 9. H is less than negative 9, so that's going to go off to the left, and I don't have much room here. So that's going to go off to the left. One of the things that I like to do is read from my variable. So I don't read left to right. I read based on where my variable is located. So it says h is less than negative 9, so I know which direction that my line is going. Number 6, we have a two-step equation. I'm going to add 4 to both sides. 3/8 x is less than, less than or equal to negative 6. And if you'll remember, what we did with the fractions is we multiplied by the reciprocal. So the reciprocal is 8/3. And I'm going to multiply by 8/3, and that cancels out and makes it just x. So x is less than or equal to, and that becomes negative 16. Again, my graph is not quite long enough. I'm going to add negative 16 there. And x is less than or equal to, so it's going to be a solid dot, and then it's going to be to the left. Negative 16. Translations. We did lots of translations in the first unit. So if we have 1/2 of x, so 1/2 of x increased by 9, so that means I'm adding 9, is less than, so there's my less than sign, 33. And here's my expression. Number 8, 6 is less than or equal to, so 6 is less than or equal to the sum of 4 and negative 2x. So the sum means to add, so I'm going to be adding 4 and negative 2x. Number 9, 4 times the difference of x and 12 is at most 16. Okay, 4 times the difference, so I need to subtract x and 12, and I know I'm going to have 16 here, but at most, 4 times the difference of x and 12 is at most 16. So that means that this is the biggest number it can reach. So that tells me it's going to be a less than or equal to sign, because it could be 16, but it could also has to be, can't go past 16. So that's going to be a less than or equal to sign. 7 decreased by twice x is no less than 20. Well, 7 decreased to subtraction 2x, and then I know I've got 20. So it's got to be no less than 20. That means 20 is the smallest it can be. So that means it's got to be greater than 20, because it says it can't be less than 20. Might be greater than or equal to, but I'm pretty sure it's greater than 20. Okay, applications. A rectangle has sides of 9 and x plus 2 feet. What can x be so that the area of the rectangle is greater than 81 square feet? Well, I'm a visual person, so I like to draw it out. So I've got 9 and x plus 2, and I'm looking at the area. So that's the space inside the rectangle. So that means my area formula is length times width. So I've got 9 times x plus 2, and it says it's got to be greater than, so greater than 81 square feet. Okay, once I get my equation set up, now I just need to solve it. So I'm going to distribute. I get 9x plus 18 is greater than 81. I would need to subtract 18. And I get 9x is greater than 63. Then I would divide by 9. and x is greater than 7. So anything greater than 7 would work in this problem. Number 8, you spend $46 on supplies to make wooden ornaments and plan to sell the ornaments for $8.50 each. What are the possible number of ornaments that you can sell for your profit to be positive? Well, I'm selling them for $8.50 a piece, and I've got to make more money for it to be positive. I have to make more than or equal to $46 because I already spent $46. I'm going to make it more than so it's positive because it has to be more than instead of more than or equal to. Okay, well this is a one-step equation. I need to divide by 850. And let's see, I'm going to get my calculator out here. And you can download this calculator online. Alright, so I need 46 divided by 8.5, or 850, and I get 5.4117. So x would have to be greater than 5.41. Well, this doesn't really make sense because I can't make 4.41 of an ornament, so I'm going to round it up to 6. It has to be greater than or equal to 6 ornaments because anything over 5.41 would be a positive profit, so I can change that to greater than or equal to because there's no way I can have 5.41. I could either have 5 ornaments done or I could have 6 ornaments done. Marcus has accepted a job selling cell phones. He will be paid $1,500 plus 15% of his sales each month. He also needs to earn at least $2,430 to pay his bills. For what amount of sales will Marcus be able to pay his bills? Okay, so if we write the equation, it says he gets paid $1,500 plus 15% of any of his sales, and it has to be at least 2,430. So it has to be that amount or more. So I'm going to use greater than or equal to. What he makes at the store has to be greater than or equal to what he needs to pay his bills. Okay, from here I'm going to solve. I'm going to subtract 1,500 from both sides. And I get that 15% of his sales is greater than or equal to 930. Then I'm going to divide by 0.15. I'm going to bring my calculator back up. And so I take 930 and divide it by 0.15 and hit enter. So he needs to make his X, he needs to sell at least $6,200 worth of merchandise in order to be able to pay his bills.